So our software testing fundamentals course, this is module 5, working with bugs. Inside this module, we'll talk about detecting software defects, also logging bugs and managing bugs. So this is going to be a buggy module. So let's move forward with the module itself. We've already talked about the components of the module. Let's start with 5.1, detecting software defects. In this section, we'll cover executing test cases. We'll also talk about running automation scripts. We have 3 guiding questions for this section. First one is, what must be configured in Microsoft Test Foundation Server, TFS, to run tests and collect data remotely? The next question is, what must be set up on each remote machine to run the tests? And then finally, what tool in Visual Studio enables the developer to execute tests and analyze the results in the test plan? Now let's talk about automated versus manual testing here, Eric. We've talked a lot about manual testing, where the tester plays a role of a user and checks to see if there's any unexpected or any undesirable behaviors. There's the automated test that really is used to test the controls and track one or more automatically executed tests. There's also test scripts and automation scripts. Can you talk a little bit about those?
Yeah, so built into Visual Studio is coded UI. So you can create coded UI tests, and you can take your manual tests and record those, modify them. We talked about this in a previous module. You can modify those, create methods from your coded UI tests, and then you can put that together into a pretty powerful automation suite.
So with automated testing with Visual Studio and Microsoft Test Manager, it really helps enable the testers and developers to run local and remote tests. However, in order to organize these tests into test plans, you have to execute the test plans, analyze the results, and you can use Microsoft Test Manager to do this. So now we're moving into managing distributed testing. Distributed testing uses multiple computers, primarily like a lab environment, to execute tests and collect data. These labs can consist of either physical machines or virtual machines. And if you're not familiar with virtual machines, it's really a computer in a computer. It's implemented via software. It emulates the complete hardware system in a self-contained software environment. Additionally, different machines in the lab can also run different environments. So you'd want to have different OSs for backwards compatibility, or maybe even for a new OS that you're looking at releasing the product on. Distributed testing is also something that's highly valuable because it requires the machine to test the controller and also the lab machines with test agents. So Eric, talk a little bit about test controllers and the test agents and how they're used.
Sure, the test controller is the back-end process. That manages the machines. So that manages anything with a test agent installed. So the test agent, that receives and runs the automation code that you've got there. So you're going to have your test controller controlling your test agents, running your test automation code.
So this ends this section. We have our section questions. What must be configured in Microsoft Test Foundation Server to run tests and collect data remotely?
So that's your test controller and your test agents.
Okay. And what must be set up on each remote machine to run the tests?
Yeah, each remote machine must have the test agent set up on it.
And then what tool in Visual Studio enables the developer to execute tests and analyze results in the test plan?
So that's Microsoft Test Manager.
Great. Let's move on with 5.2, logging bugs. Inside this section, we'll review priority, severity, dependency, and we'll talk about the repro of steps. We have 3 guiding questions as a part of this section. First is, what term refers to the impact a bug has on the overall project? Explain the difference between priority and stack rank. And then finally, what technology records diagnostic data to help troubleshoot bugs that are difficult to reproduce? Tracking bugs. As we all know, bugs and error in the code or the logic of an application that causes a malfunction or incorrect results. Application Lifecycle Manager that's a part of Visual Studio and Team Foundation Server is really there to help us create high-quality software and reduce the amount of bugs that are in that code. It also helps us to log, track, and look at how we resolve those bugs moving forward.
Yeah, and keep in mind that as you're moving forward, a bug is just a work item, and that's going to convert into, or not convert, but a work item is going to be created based on a bug that's entered. So just like any other task in the development process, that's going to be put into the queue of work that the developer needs to get done, and it's going to get prioritized against that other work. So defining a bug. Well, whenever you see these defects or bugs, a work item is created, as Eric said previously. And this is where the team will then begin to work on the potential problem and document the nature of that potential problem. Like any other work item, the bug will be managed in Team Foundation Server, and it's assigned usually to a team member, or if you're doing extreme programming, it'll probably be given to 2 individuals as a part of that team. The bug would be defined using Microsoft Test Manager. Information about the bug case, the user story, and information will be linked to that bug, which I think is quite nice in regards to the association that you see inside of Microsoft Team Manager. And it's also very important to understand that whenever you record a bug, there's several pieces of information that's usually needed, whether or not you're logging a new bug or a previously known bug. Right, so we'll start off by talking about priority. And this is something that you may or may not enter into the bug report as a test person. A lot of times priority gets assigned during the triage process. The reason that gets assigned during the triage process is that it has a strong business impact to it. So the business needs to have their voice heard here. So you can come up with a bug that's got a high severity, which we'll talk about next, but the business may not feel it has a big impact. For example, if the high severity bug happens in an admin module where there are only a very limited number of people that could come in contact with it, and it isn't likely for them to come in contact with that bug, they could lower the priority very low, even though it's a high severity bug. So many times that's left to the triage process, but priority is going to be business impact. So we'll talk about severity, and now whenever you open a bug, severity is generally going to be a required field to be filled in by the person who writes the bug. It doesn't necessarily mean this can't be changed, because it's even typical for these severities to get changed once more information is known. But the severity is going to be a high severity, might be something like a crash bug or something that loses data or puts the user into an unrecoverable state. That's going to be a critical bug. That's going to be a Sev 1 bug, as they're referred to. And something like a Sev 4 bug might be something that's visually not pleasing. Maybe it's a usability issue, or maybe it's something like a spelling error. It's not going to affect the workflow, and nobody's going to lose any data. They're not going to crash over it. But it's something that it's worth bringing up because you had a test case, the test case failed, you need to open a bug, and you need to determine the severity of that bug. Now, stack rank is something else that's decided in the triage process, because the stack rank is really, how does this compare to the work that we've already got in the queue? Is this more important or less important to work in the queue? So stack rank is going to be determined, and then that's what's going to give the developers the order that they need to go after these items and fix them.
Is there a scale that you think about as you think about stack ranking?
Yeah, I mean, the stack rank is going to have, the early ones are going to have the low numbers. So if if something has got a stack rank of 1, that's your that's your next thing in line for the developers to work on.
Okay, all right.
So the repro steps now, this is another important aspect of the bug that the test person needs to be really diligent about. So the repro steps are going to get the attention of the developer, or they're going to lose the attention of the developer. So the repro steps really need to be clear enough that in a few minutes, and probably less than that, the developer understands what the problem is, understands what the impact is, and understands how to reproduce that error. And this is probably the highest, this is probably the thing you need to do the best to avoid getting bugs sent back to you as no repro, as making sure that there's just no way that you could misinterpret the steps that were taken to cause this bug to happen.
So, logging kind of your steps, also
right.
including screenshots are very important as you think about documenting the repo of these bugs.
Right, and another will be your prerequisites to get you to the state that you were in when you did the bug. So if you were a specific kind of user, say a power user or an administrator in the system, then you did these set of steps, then you saw this bad behavior and filled in. And that's just for a UI test. If you're doing a test in the code, you're going to have to show a lot of diligence around how you did your method call, or if you're showing a bug in SQL, you're going to need to explain, what is wrong specifically there in the code, and those need to be in the repro steps as well.
Whether or not that's in the script or maybe it's a database structure issue.
That's right.
Problem. Yeah.
That's right.
Okay. All right. Great. So tell me a little bit about IntelliTrace, because I've heard this before. It seems to be like an awesome tool, to take care of those bugs that are isolated and are kind of difficult to reproduce. So tell me a little bit about how IntelliTrace works and what the value is.
So IntelliTrace is a feature for debugging a managed application at a specific point in time. It captures what exactly the person's doing. So if you've got a bug that you're kind of afraid that there's going to be a no repro resolution from the developer, IntelliTrace is a great way to go. You just kick that off, you record what you've done, and in the next slide you can kind of see what you can do visually, and you can send to the developer. They just get a file essentially, and it's kind of irrefutable evidence that there's an issue.
Okay, yeah, good. Well, that ends this section of the fifth module, working with bugs. Let's try to answer some of the section questions. First question is, what term refers to the impact a bug has on the overall project?
This is the severity.
Okay. Explain the difference between priority and stack rank.
So priority is the business impact, and stack rank is the order of the work that needs to get done for the developer.
Okay. And then what technology records diagnostic data to help troubleshoot bugs that are difficult to reproduce?
That's the IntelliTrace.
Great. So let's move on to section 5.3 in module 5 and working with bugs. This is managing bugs. In this section, we'll talk about triage, which Eric's already talked a little bit about already. We'll talk about bug resolution, talk about what's needed to close a bug, how to monitor bugs moving forward, and then also finishing up this section with the bug summary report. So our guiding questions for this module is, what does it mean to triage a list of bugs? What is the last step before closing a bug? And then finally, what is a reason for activating a resolved bug? So we'll talk about triage and how you use triage as part of your team.
Sure. In software development, the triage process is to go through the list of items that haven't been through the triage process yet, and you assign priority to them. You assign the stack rank. You make sure if there's any new details that need to come out of it, you get those logged into the bugs. Or if there's more details that you can't necessarily get from that triage meeting, you make the decision to kick those back to the person that opened the bug so you can get that information. So you send that question back to them, and then they can send it back to triage again. So on some projects, if it's a small project, the whole team shows up for the triage meeting. You've got your dev, test, PM, your business person might even be there. In a large project, you're going to have a select set of people that are going to go to these triage meetings. You might have your dev lead, your test lead, and your PM lead, and a business representative that go to this meeting.
So when you triage a bug, you have your triage meetings that happen at set intervals as a part of the development work. That may be dependent upon the development methodology you're using, whether or not that's Agile or Waterfall. Before those triages start, there's usually a set of criteria that's used to determine which bugs should be fixed and what priority. There's also the criteria that's typically identified that identifies the severity of the bugs and the bugs that are associated with certain features that have significant value or other project risks. Early in the project, you would likely decide to fix the bugs that that are in the triage. But as the project proceeds, you may change the bar relative to what bugs you will fix and what bugs you won't fix. And there's a trade-off that's associated with that. You want to talk a little bit about that trade-off, because this is really where we come to the business decision that's a part of this triage discussion.
Right. As you come closer to the end of a project, you get to the point where you have to make the trade-off decisions. And they're really difficult decisions, particularly if you've spent a lot of time testing an area and finding the bugs, to have the team tell you that even though you did your work and you did a great job and you found these great bugs, they're not going to make the cut for things that are going to get fixed. And there's really good reasons for this to happen. You've got a limited amount of time or resources. You don't want to increase the risk of changing code late in the game to fix what may be seen as a low priority issue, which again is business impact. The business may say, this is a low priority issue, and your development team may argue, this is a higher risk, so we don't want to inject some risk in at the kind of 11th hour to try to fix this low priority issue. So we may actually just say, this is going to get deferred to a later build, or this is just going to go into a won't fix bucket.
So verifying a bug fix, after it's fixed, you usually assign it to a tester to do the verification, to make sure that the problem's solved and that the bug work item's closed. When to verify that fix, the tester's going to attempt to reproduce the bug based upon the documentation that's associated with the bug, and they may reactivate the bug if necessary if they find that the outcome really doesn't meet what is expected. So they may reactivate that bug at that time. During this verification process, you may go back to the person that originally logged the bug to maybe talk to them a little bit about, is this truly what you were expecting? Because I'm seeing this. And at that point in time, you may come to an agreement that you do need to reactivate the bug. Or based upon that conversation, you may say, oh, okay, that's what we expect. We should go ahead and move on and show that bug has been fixed at that time. Bug states. You do a lot with bug states, Eric,
Sure.
in your role as a software tester at Microsoft. Take us through, what these states are, and then talk with us a little bit about how they get resolved.
Right. So as you open a bug, the first thing you're going to do is you're going to your bug's going to be in the active state. So that means that it's being investigated, or it's in the process of being fixed. So the developer will have a set of active bugs assigned to them. That's their queue of work they need to get done. Now, when they complete that work, they're going to resolve that bug, and that bug is going to get assigned usually back to the test person that opened it for regression. The test person's going to do the regression, and they're going to validate the area that it was fixed, and then they've got their choice to either reactivate it if they feel that the fix wasn't sufficient, or just didn't actually fix the issue, or they're going to go ahead and close it, which means that issue is completely resolved and that item's closed out.
So take us through the bug state diagram that we have here. We talked about active, we talked about resolve, we talked about closed.
Sure, we'll start at the active box here. So as the bug is active, and the developer will own the bug at this point, and they've got a series of choices, which is the arrow to the right. They can move it to resolve state by setting it as fixed, deferred, which means that they've had probably a conversation with program management saying, hey, I really don't want to fix this, but I think we should fix this in a future version. It could be a duplicate, meaning somebody's already opened a very similar bug, and the fix of that bug will also fix this bug, and they'll link those two bugs together in VSTF. So you'll be able to see what the duplicate is, and you can verify that as well. As designed, or by design, which means you're misinterpreting the requirement, and this is actually how it's supposed to work. Can't repro, which means the steps that you've provided aren't sufficient that the developer can reproduce it, or for some reason they're not being able to reproduce it in their environment. There may be an environment issue, and that's common too. There may be something on your in your environment on your desktop that's not in place on theirs. And then obsolete, which means this really isn't going to be an issue in the production environment. So there's something different about your environment. For example, if you logged a bug that said this application crashes when I run it in Windows 3.1, the developer is going to close it as obsolete because they're going to say, we don't support Windows 3.1. Okay. Now, after it's resolved, that's where the tester owns it again. Whoever opens the bug owns it when it sits in its resolved state. So the test will do the regression, and they can reactivate the bug, which is send it back to development. Or they can send it back to the triage team for kind of reconsideration if the developer has sent it to as resolved by something like deferred or something like obsolete. You can send that back to the triage team and say, hey, I'd like some support on this. I really don't believe that this should be deferred. I believe this should be fixed now. And they can have that conversation with the triage team and get that back in the developer's queue and say, yeah, that really does need to be fixed. Cool. The other option the test person has is to verify that fix actually is resolved, or to verify that they agree that it's by design, or they agree that this is obsolete, or they agree that, yes, I see the duplicate issue there, and I do agree that mine is similar to that, and the fix for this will fix this bug. Then it's closed out. So now a closed bug can actually be reactivated. So something that's common to do and you need to do as a test person when you're testing is to go back to the bugs that you closed before and regress those again. Just essentially try to see if that bug is kind of reared its ugly head again, which it's not uncommon for that to happen. So you go back, and if you find that there's a bug that's been re-injected, you're going to go back and you're going to take a closed bug and you're going to reactivate it and send it back to the developer. Mm-hmm.
At that point in time, if you reactivate it, you begin to work on that, you'll have to do some regression testing based upon reactivating the bug and doing that work.
You'll do some regression testing because you've realized that some bad code got injected, and you're going to want to look around and see if other bad code did too.
Sure.
And then when that gets fixed again, you're once again going to regression test all the areas around that. And you know, when you get close to the end of a test cycle, you really are regression testing the whole application.
Okay. So here's some reasons for reactivating a resolved bug. One, it's not fixed, as you mentioned, when the resolution is unacceptable or if the fix was incorrect. The other one is when the test fails. The test that you've created demonstrates that the bug is, it still exists and we're not getting the output that we expected. There's also reasons for reactivating a closed bug. One is through your regression testing. So as you regression test the bug, it reappears later in the code. Or you may want to reactivate it when the bug was closed in error or for some other reasons. So Eric, you're very familiar with these bug status reports because you look at these on a regular basis. Tell us a little bit about, one, how often you review these reports. Two, who gets these reports? Do you provide these reports to your customer, your business customer? What are some of the things that you look for in these reports as it relates to the performance of your team?
Right, so generally the bug status report, it's all going to depend on the size of the team. You know, if I'm on a large team and there's several people working on that team, I'm the test lead of the project, I'm looking at this bug status report every day and probably several times a day. I'm kicking out a new report or I'm looking at the metrics. Now, I'm reporting out probably once a week, and this report is going up my management chain, it's going to the program management chain, and it's going to the development management chain. So everybody gets a real good feeling for what's going on in the test world and how our bugs are trending.
Okay. So the data that's shown on these bug summaries includes number of bugs, active bugs, by severity or by priority. There'll be active bugs by assignment, so we'll be able to see all the bugs that you have, or maybe Andy or maybe Don, members of your team. We'll also see resolved bugs by assignment, so we'll be able to see how many people have been able to work on those bugs and get those resolved in a timely fashion. So let's go ahead and move forward with our section questions. So that ends our section and also ends the module. But what does it mean to triage a list of bugs?
That means to review with the dev, test, and PM, assign priority, and the resource that's going to resolve that.
And then what is the last step before closing a bug?
That's verifying the fix.
And then finally, what is the reason for activating a resolved bug?
So you'd reactivate a resolved bug if, as the tester, you didn't agree with the fix or you felt like there was more work to do.